So welcome everyone in this new video. In last video we discussed about the some concept of pure rolling, and we find out the time after which the body starts pure rolling. In this video we will discuss about the concept regarding related to friction. As you seen that in a pure rolling motion, let's suppose this is a body and this is a surface. This is a point of contact. Let's suppose this is P, and as we discussed that here is velocity V, and in this direction there is a R omega, and for pure rolling we discussed V equals to R omega. So according to the concept of pure rolling, that there is a no relative motion, since both the velocities are same, so there is no relative motion. So the question is there any force of friction is exists or not? So since what is the definition of friction? The definition of friction is that the friction opposes relative motion, and if there is no relative motion, and here is no friction force will act. So now the question is, if the relative motion is not there, friction is not there, then how this point is moving, isn't it? So in tangential direction there is no force, but there is a force, that is centripetal force, because it is rotating in a circle. So because of the centripetal force, this point of contact will move in upward direction, and when it goes in forward direction, then next point will become point of contact, and then again its relative motion zero, and again because of centripetal force this move in upward direction. So in this manner the body moves in forward direction. So that is another thing. Now main thing is here the friction. So here in horizontal there is no friction force when the body is in pure rolling motion. Let's suppose if apply force on this body F. Let's suppose initially this body is at rest, and I apply external force on it. So what will happen? The external force will provide it a linear acceleration. Also it's rotate this body in this clockwise direction, because this is force and this is, let's suppose this is r in this direction. So r cross f, so it is, so omega should be in this direction. Okay, so what will happen? This start rolling. So because of its force there is an acceleration, and because of this rotation there is an acceleration, that is equals to r alpha, or we can say there is velocity and also r omega, both will here. So what will happen after some time? If there is a friction, so if this point starts moving in this direction, so in which direction we need a friction? So we want to decrease this acceleration and increase this r alpha. So friction should be this in this direction, because if friction is in this direction then it will support it and reduce it. So we don't want it. So we want the friction so that it can reduce the linear acceleration. And since here, see, this is r vector, and if I use right hand rule, then r cross f is clockwise direction, then it will provide a acceleration in clockwise direction, and this will increase this, and it is after time t a equals to r alpha, and this is also the condition of pure rolling. So here what kind of friction force is acting? This friction is static friction. Why the static friction? Because the value of this friction force is only that needed to reduce it and increase it. only that value it will take. And if this is kinetic friction, if I applying force and this is a kinetic friction, that means the friction is not sufficient to prevent this point slip, and this is slipping, then pure rolling is not possible anyway. But you okay, so there will be, if this body is doing pure rolling, then the friction is static, and if this friction is kinetic, then the body will never get a pure rolling motion. Now the question arises, in a last question, as we discussed in the previous video, we said that in last video we said that there is a body and it is moving with velocity v naught, and here the friction force will act, and that is equal, value is mu mg, and that is the friction value of the kinetic friction. So why here the body will come in the pure rolling motion? That is the question. Okay, so in the last scenario, the force, we are applying a force, and that is providing its a acceleration, and in this case this body only have linear velocity, there is no acceleration in this direction. So because of this, the velocity will come, and r omega of this, because of this, will increase, and at a certain time t, both are equal. But in the previous case, f is continuously providing it a linear acceleration, so that if the friction is not sufficient, then there is no chance to get a pure rolling motion. So I think you understood the difference between both the cases. So that's all for today. We will next in new video, and if you are here till now, then like and subscribe this channel. Okay, thank you.